everybody. Today we are starting on page 14 in your packet, and we're going to get into proving triangles are congruent. And this is something that you have not worked with before. It's a little bit tricky, and we're going to practice with it for quite a few days. All right, so again, it's really important that you're not only watching, but also turn your sound on. You need to be listening to this. All right, so proving triangles are congruent, or proving triangles are the same size. We're going to start with a hypothesis, and then we're going to kind of, look at what we have and make an assumption based on definitions, givens, the information they give you, postulates, properties, theorems. Those are all just different rules that we know about triangles, and then we come up with the conclusion. So just a few properties that we have not talked about yet, but something that you'll definitely need to know. The first one is the reflexive property. This is one that we will use quite a bit. All right, I'm actually going to put a star by it. The others we don't really use anymore, but the reflexive you will see. And the reflexive property is something, basically states that something is always congruent to itself. Which you might say, well, why would I have to say that? With proofs, you have to state everything. And you'll see when we get into it. So it basically says segment or side AB is congruent to side AB, or angle A is congruent to itself. There's the symmetric property, which isn't used as much anymore, but basically you just change the order. So if A is congruent to B, then B is congruent to A. If AB is congruent to CD, then CD is congruent to AB. It's just changing your order. And then the transitive property, again, we don't really use anymore. We may see it come up. If A is congruent to B and B is congruent to C, then A is also congruent to C. So basically, if two things are congruent to the same thing, they're both congruent to B, then they're congruent to each other. But again, the one property that we'll use for sure is the reflexive property. I honestly don't foresee the other two coming up. All right, just a couple other things that we've talked about, but just a reminder so we have it all in one place. Bisect means to cut in half. It could be an angle that's cut in half or a segment. Either way, it makes two congruent parts. And read it carefully. If it says it bisects an angle, don't say that two sides are the same. All right, midpoint bisects a segment into two congruent segments. So these two are very similar. Perpendicular, if it tells us something's perpendicular, we know that there's 90-degree angles there. And vertical angles are formed by intersecting lines, and they are always congruent. All right, so if you see something like this, we know that this angle and this angle are congruent. And a lot of times we're going to use numbers instead of using the letters, angle ABC. We'll just say angle 2. All right, so there's a bunch of different ways to prove that triangles are congruent. There's actually 5, and we're going to just talk about the first 2 today. So there's side angle side congruence is the first one. And what that is, and we'll just write SAS. You won't have to write it all out. If you have a side, or basically two sides in the included angle, so the angle in between them, congruent in one triangle to the two sides with the congruent angle between them in another triangle, then you can say that the triangles are congruent. So what this is saying is triangle ABC is congruent to triangle EFD because A and E match. And look at where their order is here. We talked about similar triangles yesterday. Side AB, so your first letters are congruent to EF. You can see the same marking, and same with DE and AC. So if you have side, angle, side, if you follow a path, it's the two sides with the angle between, then your triangles are congruent. So this first one, explain why triangle XYZ is congruent to triangle BWZ. All right, so we have angle 1 and angle 2 there are congruent because they're vertical. All All right. And then you've got the two sides with the angle in between. Same over here, side, angle, side. So that it is side, angle, side of one triangle is congruent to side, angle, side of the other. All right. And angle 1 and is congruent to angle 2 because they're vertical. And we'll get into all this. All right, so this next one, we have side, angle, side as well. A lot of times that's not given to you, or that little X is, because that's your reflexive property. BC is congruent to itself regardless of the triangle you're in. So either way, you have side, angle, side, side, angle, side. So they're congruent by side, angle, side. And again, that's an example of your reflexive property. All right, the other one is side, side, side congruence, which means if you have 3 sides in one triangle congruent to 3 sides in the other, no angles needed, then your triangles are congruent. So let's take a look. This is an example of a proof. I have it set up for you. Typically, this is all they're going to give you right here. And you cannot assume anything. So it gave us that AC is congruent to BC, side CD bisects angle ACB, and we need to prove that triangle ACD is congruent to triangle BCD. All right, so first of all, you're going to have a 2-column proof. The first column is all of your statements. The second column is all your reasons. All right, your statements, you make a statement, and the reasons, this is your why. How do you know? And I started it off for you, AC and BC, and it are congruent, and CD bisects ACB. We know that because it's given to us. So that's our reason. So the next thing that you need to do is you need to mark things off on your picture. If you don't mark your picture, it's going to be that much harder. So AC is congruent to BC. Let's mark that. AC is congruent to BC. All right, so we have a side. I'm going to put a little S there. Now, CD bisects angle ACB. Angle ACB. So this angle right here is being bisected. All right, so that means that if it's being bisected, it's being cut in half. This is congruent to this. And that's going to be one of our statements. And instead of saying angle ACD and BCD, we're just going to call those 1 and 2. So let's start there. I can say angle 1 is congruent to angle 2. Again, you could use the letters from the picture, but if you use the letters, the order is important. So if you say angle ACD, you have to go in the same order, BCD. All right, but you can just put a little 1 and 2 in there and use the 1 and 2. And the reason that we knew that those were congruent, because of this word bisect, so you just say definition of bisect. Or you could also say of angle bisector. Definition of angle bisector. Either way. So now we have the angle. All right. So I'm not doing side, side, side because I don't know anything about these sides. But what we do have, we have side, angle. Look at this side is shared. CD is congruent to itself. So I can say CD is congruent to CD because we're in 2 different triangles. Side CD is congruent to side CD, and that's our reflexive property. All right, so now if you notice, we have side, angle, side is congruent to side, angle, side, so we have met our requirements. So you just write this for your final step, whatever you're trying to prove. Triangle, we've proved triangle ACD is congruent to triangle BCD, and we used side, angle, side is congruent to side, angle, side. All right, let's look at another one. I didn't get it started for you. So it gives us this a picture and wants us to prove that the two small triangles are congruent. So the first thing you're going to do, set up your 2-column proof like I had above. So statements. You're going to make a statement. You're going to tell me something. And then reasons. Remember, this is why you told me that. All right, and the first thing we're going to do is write down our givens. Pn bisects MO. And Pn is perpendicular to MO. And the reason for both of those is they were given. All right, so let's first, before we get too far, let's come up with a plan. So let's mark our picture. Pn bisects MO. So MO is what's being cut in half. So MO is being cut in half, right? So I can say MN is the same as ON by definition of bisect. I'm going to start there. MN is congruent to ON. So those two sides are congruent. And the reason, definition of bisects. All right. Now, it didn't give us the angle, but it did say Pn and MO are perpendicular. So what's the definition of perpendicular? These angles are right. And I'm going to call them again. I'm going to call them 1 and 2. And then look at, we'll be able to tell this side. And again, you have side, angle, side, because you have that the side is the same because it's the same segment. Okay, so let's deal with that perpendicular. So angle 1 and angle 2 are right angles. Can't jump to say that they're congruent yet. We're going to say that they're right. And the reason that we knew that they were right was from this right here. Definition of perpendicular. And you can use the symbol. All right, now we don't have the angles yet. Now we can say angle 1 is congruent to angle 2. Oops, let's call that number 5. And the reason, all right angles are congruent. Okay, so now we have an angle. So we have a congruency statement for the side, the angle, but now we haven't said this yet, but Pn is congruent to itself. And do I have to go in this order? No, you could have done this right away. And the reason that we know it's congruent to itself, that's your reflexive property. All right, so we've said that those sides are congruent, those angles are congruent, and those sides. So we're ready to go. Triangle MNP is congruent to triangle ONP. And the reason we know side angle side of one triangle is congruent to the side angle side of another. All right. Let's look at one last example. So AC is congruent to BC. They've already said that. So A to C is congruent to B to C. So there's a side already. And the reason we knew that, given. And I usually start my proofs off, just immediately copy down my givens. And D is the midpoint of AB. So if D is the midpoint, then AD, I'm going to use different markings, is, because we already used those, is congruent to BD by definition of midpoint. Oops, that was given. Sometimes it'll show this in 2 steps. It doesn't matter though. If you say, AD or segment AB is bisected by definition of midpoint, then you can say AD is congruent to BD, but you don't have to go through both steps. Okay, now we have a side. We have another set of sides. But we don't have an angle. It doesn't tell us anything about this angle being bisected. It was just this segment. You cannot assume that this is perpendicular. All right. If it doesn't say it up here, you cannot assume it. But we do have one other thing that's the same on both triangles, and that's that shared side. So once again, we can say CD is congruent to CD. And don't change the order. Don't say CD is congruent to DC. Just that segment's the same in both triangles by the reflexive property. And what we have is 2 congruent triangles by side. So that was that second one that we talked about. ACD is congruent to triangle BCD. And that's because all 3 sides of one triangle are congruent to all 3 sides of the other. All right, I'm actually going to stop there. We're going to get into more of this tomorrow. If you want to give this one a try and see how you do, and then we'll look at it in class, that's fine. But we'll get some more practice in with this, and then just continue on with it. All right, it is a little bit tricky, something we haven't done before. But again, lots of practice the next few days with these. And just remember, you cannot assume anything. Just go by your givens and your rules. All right, so we'll stop there. Have a great day, and stop by the Math Lab if you have questions.